Alright, so today we'll continue from last time, the question and answer for photodetector group. Okay. Can I know who's, can you remind me who's in the photodetector group?
Me and
Give me the name. I don't want me. Give me your name.
Amirul Faris,
Hmm.
Said Zarif,
Said
and
Zarif.
Haris.
Lagi? 3 orang ya?
Haris.
4.
So all of you are here?
Yes, madam.
Yes, madam.
yes, madam.
Okay, I open for the floor to ask question. Based on the presentation last time, each group should ask a question. Okay, who wants to start first? All of you should already jotted down the question, right? Tak pun saya tolak je lah markah setiap group.
I have a question.
I give you 2 minutes. 1 minute je lah. Who wants to start first?
I have a question, madam.
Okay, Farhana.
Is it good to have higher dark current?
Okay. Who wants to answer that?
Me.
Okay, Muhaimin.
Okay. So as you can see, the dark current is actually a leakage current. Okay. So if you, let's imagine that you have something that you cannot control. The leakage current is something that you cannot control. So it will be bad for you to have a higher dark current actually. But that it depends on your application. So if you need something that high speed, so you need something with the low dark current. But if you such as the silicon, but if you need something that in the low speed, so you will need a high dark current such as germanium.
Why do you need a high dark current?
So it will be a high speed. The speed.
Why high dark current, high speed?
Low speed, dark current is high, but for the high speed, dark current is low.
Isn't it better to have a low dark current with low speed as well?
I think no.
Why not?
Yeah. Dark current is apa? For the thing of they tend to be high dark currents. That varies directly.
Other members can also help. Nobody wants to help? Nobody wants to help. Okay. So you are not sure whether if it's low speed, you should have low dark current or no, right? What is the, okay, since we are in the dark current question, Zarif, what is the impact of the dark current? What does it impact most?
Impact most.
Mm.
Dark current. Is it the speed of photons or what?
How does it affect the speed?
Uh,
If you answer the speed lah. I'm not saying it's right. I'm just provoking you.
oh. Mana?
You know, you don't know.
I don't know.
Okay. Who wants to answer my question? What does the impact of dark current, the main impact of dark current to the photodetector?
It needs a higher level of photon energy to produce a useful current that's higher than the dark current itself.
So what does it affect? So what's the main parameter does that affect?
Responsivity.
Why responsibility? What is responsibility?
Because if the dark current is already at a certain level, then the photodiode needs to produce a higher current than the dark current itself. So a higher power of photons needs to strike the.
I know what you say responsibility. What is responsibility?
Yeah, now that I said, I'm also not sure about that one.
Okay, don't answer things that you are not sure, because otherwise I will ask you. So basically, so you are still not answering my question. What is the parameters that most affected by the dark current? Tinggal seorang je lagi, Amirul Faris, to try on this.
Madam.
Dia boleh jawab soalan saya. You want to try?
No, madam.
Sorry, no?
No, madam.
Tak dengar.
Hello, can you hear?
No, but, everybody can hear clearly ke saya je yang tak dengar?
Dengar, madam.
Dengar, madam.
Dengar.
You can dengar clearly?
Yes.
Yes.
Something wrong with mine, You go on. Amirul Faris,
Yes, madam.
do you want to answer that question?
No, madam. Sorry.
Saya want dekat maximum dah. Something wrong ke apa? Okay. The answer is dark current is very important for photodetector. So saya kena tolak markah sikit lah of this group. Sebab dark current is actually a very important parameter for photodetector. Why? It's not important for laser or LED. Laser LED does also have dark current because it's just a measure of the current in the dark. And the dark current can be both forward and reverse. But however, for photodetector, it's very the main importance is the reverse current. Why is not the forward current? Sebelum saya jawab, Zarif, I give you a second chance. Why is the in photodetector is most important in the reverse bias, not the forward?
Because to obtain a higher efficiency.
How?
Because by increasing the depletion region compared to forward bias, obviously they have a smaller depletion region.
So what does the depletion do to the efficiency of the photodetector?
So whenever the depletion region is higher, the electrical field is
Dia panggil bigger, depletion region bigger.
bigger. The electrical field will be higher. So the strong influence of the electrical field will cause the movement of the photon energy, the holes and electrons, to produce a current.
Boleh lah. Dia taklah salah tapi dia taklah tepat sangat, tapi it's okay. I can understand what you're trying to say. I hope the rest of you understand because you have to answer tahu in the exam. You better ask now brothers sisters yang tinggal 15 orang. I don't know where the rest of the kita pun orang kelas kita biasa 20 tak? Ke?
Sampai ke
17.
Only 17. So 2 missing. Okay, so yes, for photodetector, reverse bias is very important because it's more sensitive to generation of current. In forward bias, it's not sensitive because you already have a lot of current. How do you differentiate between the photocurrent and the current due to diffusion? Cannot. That's why we use the we use the photodetector in the reverse bias so that we can differentiate the photocurrent compared to the normal current, the diffusion current or the drift current. Sebab dia tak ada current kan, reverse. So the only current that we produce is the photocurrent. Photocurrent means current which is generated due to photons, lights coming in. Now, to answer what's the dark current affect the most is the parameter is the noise. It affects the noise of the photodetector. So if the noise is high, so this is what Haris is trying to say, but I want to hear the name of the parameter. Basically, it's the noise. So if the noise floor is high, so that's why you need to put more intensity to overcome the noise. That's what Haris is trying to say. So higher dark current means higher noise. Noise is always not good, whether it's low speed, high speed, Muhaimin. So you always want to have a low noise. However, how low is the noise floor, it depends, again you are right, it depends on the application. Some applications are very sensitive to noise, some are not. It depends also on the intensity of the incoming light. So if the light is a lot, so it can overcome the noise. Tapi kalau light tu sikit kan, you want to detect light, but the light is very, the intensity is very low, so you are fighting with the noise. So in the end, you won't get the correct detection of the light sebab dia akan bercampur aduk dengan noise. Okay, so next group ask question. Thank you, Farhana. Next group.
My group, madam.
Okay, Anas.
My question is, what is the sensitivity of the photodetector to different colors, which is different wavelength of light?
Who wants to answer?
Come again, Anas.
What is the sensitivity of the photodiode to the different colors?
So for different kind of light, you have like UV and infrared, right? It depends on the materials of the semiconductor.
Does that answer, Anas?
I mean that. So does that mean that for every colors we should have different materials?
Every color, as in visible light. Visible light doesn't require special materials, but for infrared and UV, it needs each spectrum of the light needs a certain material. Yes.
Okay.
So, apa yang okay, Anas? You tell me.
Yang each material corresponds to different different light colors, different wavelength.
Different wavelength, not colors, wavelength.
Wavelength.
Okay, alright, it's not wrong, but I can provoke a bit to, it's not really accurate, but it's okay. Okay, good. Next question.
Madam.
Yes, Azian.
To generate electron horsepower, the and
Azian, lag.
and the photon energy like that.
I think it's tak dengar tadi. Maybe boleh type.
Azian.
Lag. Sorry. To generate electron horsepower,
okay,
the photon energy need to be higher than the band gap, right?
Yes.
Okay, so what is this must have? Why it's like that?
Why is it like that?
See it like that.
Siapa nak jawab?
Dah nak jawab?
Nak jawab.
Silakan.
Why is it like that?
Siapa nak jawab?
Meon lah.
Okay, can I try first? Okay.
Okay.
Boleh. Okay. okay, the what we call that, not the principle, but kefahaman, something like that. It seems that in order for the structure or an atom to be initially break down into an electron hole pair, the photon energy needed to be higher than the material band gap.
Yes, she's asking why.
Oh, why?
Kan, Azian? Is that your question? Why? Dia tanya why. Awak repeat je soalan dia tadi tu. So, who wants to answer?
I think I just answer this question.
So, because the four of you supposed to be the expert of photodetector now. Silakan.
Kenapa?
Siapa nak jawab?
Dia apa tu? Macam yang Meon cakap tadi, dia kan initially neutral electron hole pairs kan. So those yang the hole pairs tu, it will break up into free electrons and free holes. Tu kalau tak ada lah. So there will be no current lah. If the yang band gap tadi, photon
energy.
Photon energy.
Lagi rendah daripada material.
Why? Apa kenapa kena tinggi? Why does it have to be bigger than the band gap energy? Why? If it's less, then what happens?
Sebab
you know the answer this.
Because we need to excite the electron. So we need to make sure that the band gap is so we need to make sure that the photon energy is higher than the band gap energy.
Yes, otherwise it will not have enough
enough energy to jump to the conduction
overcome the band gap.
Overcome the band gap.
Overcome the band gap.
Ya Allah. Okay, make sure you answer like that lah, in the exam. Okay, so it's very basic. Is the generation of free carriers that we talked before. In order for you to generate the electron need to have an energy the same or bigger than the band gap. So the energy can come from the temperature or the energy can come from the light. In the case of photodetector, the energy is taken from the light. So the light, we shine the light to the photodetector. The energy, the photon energy will be absorbed by the electron and use that energy to being excited to overcome the band gap and then go to the conduction band. That's how you get free carriers. Okay, ada group yang tak tanya soalan lagi? Yes, Afiq.
I have a question. So previously, we did learn something about quantum well, right? So is there any application of quantum well for photodetector? And if there, then how does it affect the efficiency compared to normal?
Okay, thank you. Who wants to answer the question? Saja Pumas.
So
in my concern, I didn't find anything to quantum well.
Amirul?
In our research, we didn't find anything related to quantum well yet.
Oh, ya ke? Berapa lama buat research tu? 1 minit ke berapa minit?
Not like 1 minute lah.
Tak 1 minit lah. Maybe ada 10 jam.
Seminggu lah.
Something like that lah. Didn't count the hours. Yeah.
Cannot count the hours lah. So ni kalau seminggu kali 4 orang, it should be 4 weeks, a month worth of research, right? Sepatutnya lah. Sebab ada 4 orang. So kecuali lah seorang tu buat setengah jam je. Kalau setengah jam kali 4 per jam je dapat, right? So the answer is tak ada yang nak jawab, saya jawab lah. So the answer is there is. Okay, however, it's not very popular. Since quantum dot sebenarnya ada, tapi dia still dalam macam research, dia tak pakai commercially as macam LED. LED, quantum well LED you can buy anywhere very cheaply nowadays. However, the quantum well photodetector or quantum dot dia for very niche application sebab dia macam very niche application. Mungkin because of the efficiency, they don't see much difference in the efficiency for the difference between quantum well dengan normal heterojunction. So tapi memang ada research, a lot of research they see, tapi macam dia tak sampai commercial lagi sebab tu kot out yang 4 minggu tu kan buat research tak jumpa kan, mungkin sebab tu lah kot kita husnuzon. Okay, so any more? Group yang tak tanya soalan? Tak ada. Okay, my turn. Okay, can't wait for my turn. So I think the best part of semiconductor devices class is this part lah to me. When you present, I don't have to present. I can ask any question to all of you, and I like to see how you think. So memang it force you to think. Biasa macam ni lepas ni orang kata, student saya selalu kata apa barai. Saya generation saya tak guna perkataan barai. Dia kata dia rasa barai yang every time jumpa saya penat sebab kena pakai otak. Okay.
Yes. This is right.
Siapa ada bercakap ke?
Oh, okay.
Oh, cakap telefon. Saya mute lah awak ni. Okay. Alright, so question pertama. Zarif, are you there? My first question is to you. So saya tukar orang lain. Lah. Siapa present last hari tu?
Islamization ke atau application? Saya.
Haris. Okay, Haris, can you explain? Tapi yang ni dah tanya tadi kan. Tapi saya tanya je lah. Can the electron be excited by any kind of light?
Yes. Any spectrum of light, whether visible, UV or infrared.
For any photodetector?
Yes. You just need to make sure that the material matches the wavelength of the light.
What do you mean by match?
Some materials are more sensitive to certain wavelengths of the light.
Okay. Question number 2 to Zarif. Zarif. Tak tahulah siapa. Okay, this is who presented the how does the photodetector work? Siapa present itu?
Saya.
Okay, so the question goes to Zarif. Electron hole. When we reverse bias the photodetector and we collect the electron hole pairs, what is because when Mohammed presented, he didn't mention the mechanism at which the electron hole pairs were detected. So how was it detected and using what kind of mechanism? To Zarif.
Zarif, commute.
Oh, sorry. Regeneration, madam?
No.
Hello?
The
mechanism.
Mechanism where you collect the photo current. The current mechanism.
Mechanism.
Is there any mechanism? But we learned already before. So when it's detected, detected tu maknanya when you generated the electron hole pairs. So then the carriers have to move. So what is the mechanism that the carrier move?
Oh.
Mohammed dah. Oh, Zarif jawab dulu.
Apa? Point.
You know, you don't know?
Ni medium apa ni? Balance ke impact ionization bukan
Dan
bukan. Release elektron bukan release elektron whole pair bukan. Mana regime
Okay.
avalanche
Avalanche?
Bukan.
No.
Ionization.
kan
Bukan.
Bukan.
Okay. Who else wants to help?
Drift.
Oh current drift.
Drift. So why didn't you mention this before, Muhaimin, masa presented?
Terlupa.
Okay, it's very important part of how the detector
Sorry.
works. You need to explain that in photodetector, the main current mechanism that we detect are the drift current, which is the opposite of the laser LED, which is the diffusion current, right? The diffusion current make the recombination. In reverse bias, the drift current is important. So, so that's the mechanism lah. Okay, next question.
Okay.
Yang ni masa Muhaimin present juga sebenarnya saya tak pernah faham sangat. Tapi saya tulis dan jot down this question lah. Mungkin Zarif boleh try lagi, tak tahu mungkin awak memahami Muhaimin lebih daripada saya. Why do you mention about the total current during the presentation?
Yes.
Which I don't understand. Why do we need to know the total current, Zarif? What is the total current and why do we need to know the total current?
Why we need to measure the total current? Sebab
What is the total current? Kau tak faham macam saya juga. Awak Muhaimin, awak explain tak ke grup awak ni, ke Zarif?
Explain.
Okay. So Zarif, awak sihat tak hari ni Zarif?
Sihat madam, sihat.
Okay. So cuba jawablah soalan saya.
The current apa?
So saya tak faham, to be honest. Nanti okay, tak apa, kita suruh Muhaimin explain Muhaimin. Apa benda total current tu?
Okay, so basically the total current is a current that we get when the light is emitted at the photodiode. So meaning that if we need to measure the total current, we need to know the dark current and also the current that being produced by the photodetector. So there are two current.
So is the total current important?
No.
What is important?
Dark current.
Huh?
Dark current actually.
Dark current lagi important?
Tak. Sebab dark current tu umpama dia minority. Dia macam minority. Macam ni nak cakap ah. The weightage of the dark current compared to the photodetector current. Dark current ni macam kecil macam.
No, so what is important then? I don't understand. So I think Munirah also confused. Kan Munirah kau faham? Tak, dia tak faham. So sian dia nak jawab exam tak boleh nanti. So macam mana ni? What is total current? Why is it important? Or is it important or not important? How?
Nanti saya explain yang tanpa fikir apa fikir.
Awak explain tu tak salah dah tapi tak clear. Saya tak kata awak salah. Cuma tak clear. So macam dia macam tak bang on. Orang tak faham kalau awak explain. Kawan-kawan awak tak faham. Saya mungkin faham lah sebab saya dah faham sebelum ni. So I'm trying to help your friends. So siapa dalam grup nak tolong?
The photon current just needs to be higher than the dark current, isn't it?
So what's the total current? Is it important or no? That's my question.
Yes, I think
Why?
it should because it's the total of the dark current and the photon current. If the total current is equals to the dark current, it means that the photodetector isn't
Ha?
producing any photon current.
Tak faham Haris. Saya tak faham. Boleh repeat? Tahu Farhana faham ke? My sisters. Do you understand Farhana?
Sorry madam, my connection is not good. I
Oh.
don't.
Lagilah kesian dia. Okay, tak apa. Nanti you tengok je dalam video. Nabiha, faham tak Haris jawab? Nabi.
Tak madam. Saya putus dengar dia tadi.
Awak pun internet tak bagus? Okey, mungkinlah. Kesian awak. Mujurlah yang dalam grup ni, okey. So macam mana ni? Saya tak faham ni Haris. Mirza faham ke? Okey. Mirza pun senyum, tak faham juga. Macam mana ni? Group photodetector. You need to help your friends. Explain again.
May I try, madam?
Silakan.
Bismillah. The total current is important since that in the application of photodetector is require the bigger output, the bigger current output. So if it's not that the current is not important, it's like it is better to have more current since like Muhammad said, dark current indeed has less value than the photodiode current.
It can be, the dark current can be higher than a photocurrent. It can be.
It can be.
When the light intensity, I mean the photon, the light coming is lower than the temperature. The dark current, the mechanism for the dark current is actually the generation due to temperature. So maknanya it can be, if the temperature is high, your light intensity coming is low, your dark current can be higher, which means that you are measuring only the noise. You're not measuring the incoming photon. Saya nak jawab ni, saya tahu jawapan dia, sikit lagi. You want to try or saya jawab? Sebab apa saya jawab?
I think for the sake of time, madam jawab kot.
Baru ingat orang nak berjuang lagi ke tak? Aduh.
Dia macam dah jam, dia macam dah jam.
Apa jam lah. Okay. Ingat ke Muhammad dia yang explain.
Saya explain sebab saya cuma nak bagi tahu dia punya relation dark current dengan dengan photodetector current tu. Tak sangka video nak mendalam lagi.
Aduh, memang berhati-hati bila you present anything. Anywhere kat mana-mana pun, kalau you present something, make sure you know everything that you presented. Otherwise, you don't present. Sebab bahaya. Kalau apa-apa pergi interview ke apa-apa ke, whatever you say, make sure you know. Because orang yang, biasa orang yang cekap dia kan ambil yang tu. Dia takkan ambil yang awak dah tahu tu. So saya tahu awak tahu dah. Saya nak test your understanding. So jawapan dia lah, brothers and sisters, actually it's important. Why? Because when you sepatutnya macam ni, bila when you got, dia macam circuit tu bodoh je. The detector is very stupid. In the end, when you connect your photodetector to a multimeter, what comes out is the total current. Dia bodoh, dia tak tahu benda tu dark current ke photocurrent. So multimeter kita pun bodoh. Sebab tu manusia ni yang kena cerdik. So bila once you got the value of the total current, therefore you need to find out what is actually the value of the photocurrent, right? You don't want the value of the dark current. Therefore, if you know the value of the dark current, the value of the photocurrent is the photocurrent equals to the total current minus the dark current. Okay, so your aim is to get the photocurrent. You don't want dark current. Tapi dark current tu ada, dia menyusahkan sebab tu nama dia noise. But without any light, if you don't, dark current can we measure in the dark. So if you don't put any light, you switch off everything, you know the dark current. So you know the value of the dark current before anything. So whenever you do any measurement with the light, there will be always the dark current there. So the photocurrent will be the total current minus the dark current. Therefore, total current penting lah sebab that's how we measure the current. Clear tak?
Clear, madam.
Okay, good. Next question. Siapa saya tak tanya lagi ya?
Saya.
Siapa? Amirul.
Amirul Faris. Yes.
Amirul Faris. Siapa yang explain about the speed of the photodetector? Awak ke?
Speed of photodetector.
Speed parameter.
Siapa?
Saya.
Baiklah, saya tak. Awak menarik banyak benda-benda yang saya keluarkan soalan daripada awak punya presentation. Okay, Amirul Faris, my question to you. Why speed of the photodetector important?
Why speed of photodetector?
Is it important or no? If it's important, why?
Okay, let me think first.
Yang lain boleh fikir ke jawapan lah. Saya tak tanya lagi soalan what affects the speed of the photodetector. Yang siapa nak get ready with the answer boleh lah. Tapi ni, is it important or no the speed of photodetector and why?
So junction, okay.
You tembak salah pun tak apa, jangan senyap. So apa-apa you tembak dulu, kalau saya salah, terima je lah salah. You know, dia kena berjuang, apa-apa pun you berjuang. Mati di medan perang tu tak apa.
Saya berjuang dulu lah, madam. Okay. Saya rasa I think it is not important.
It's not important?
It is not important.
Not important. Ya ke? Why?
Why? Because in my understanding, like kan, in photodetector, we mostly use reverse bias, so that apa yang aku cakap ni? It is important, madam.
Important ke tak?
Important.
Important pula. Okay, important kenapa?
Sorry, madam. Okay, it is related to the electric field.
Why is it important?
Okay. Let's explain first. Okay, it said that by having the greater electric field, it can speed up the moving of the charge carriers from.
So that saya tak nak tahu pasal electric field. The electric field will make it faster, but I want to know why is it important?
Why is it important?
Kalau saya nak beli, saya kena tengok ke speed of the photodetector. If yes, why?
Speed of photodetector. Oh, I thought the other speed. Alright.
Kita apa benda lah tu?
Tunggu Muhaimin. Faris tak give up lagi.
Give up.
Aduh, give up awal ni. Jam.
You want to try still or no?
Apa lagi, this time saya give up kejap.
Saya ganti. Saya stop. Okay, kalau ikut macam yang tadi what you said, that if you want to buy the photodetector, so we if you said that we want to buy the photodetector, we need to see the speed. So the speed is when the light is being illuminated to the photodetector, and how fast that it will produce the current.
So is it important or no?
Important.
Why?
Because the more the faster it will produce the current. The faster the apa benda lah tu? Bila kita illuminate dengan photodetector tu, lagi dengan cahaya, lagi cepat dia produce current, lagi better lah. Jadi important lah sebab dia boleh lagi laju.
Yeah, it can detect changes lagi laju.
Yes.
So,
can you imagine? I will tell you a situation why the speed is important. Let's say you awak semua 4 orang go for a battlefield, pergi perang. And then at night you don't see. You can only use your the infrared goggle tu kan. Infrared goggles is actually using photodetector. It's detecting infrared. Infrared is a type of light. Okay, so tiba-tiba out punya foto goggle tu, orang tu dah berjalan 5 meter baru awak nampak. Sebab slownya detektor awak dan mati kena tembak macam tu je. Right? So speed is very important for certain application. Macam tu lagi. So that's the answer. So certain application is important, especially for military. Also for example kalau awak buat unify, awak ada unify kat rumah awak, ada pakai fiber optic. Kan fiber optic tu. You know how they transmit the data using apa?
Using laser.
Light kan, cahaya kan. We talking about cahaya light, laser. So dia transmit guna light. Kat hujung ni ada apa?
Photodetector.
Ada photodetector. Katalah speed of your
receiver.
photodetector slow. Kan? Orang hantar, kita dengan zoom ni, cakap 5 minit baru orang tu dapat. Dan tak sakit jiwa. So there are certain application where the speed is important. So that's the answer lah. Okay, so okay, good. Next. Speed ni saya tanya Farid lah. Okay, Muhaimin. Why is pin photodetector better than normal PN diode?
Alhamdulillah. Okay.
Alhamdulillah.
Jawab.
Gelak dulu. Okay, sebab PIN, when we use the PIN, we have the intrinsic, the eye layer. So the eye layer is actually defining the depletion region compared to the PN. The depletion region is based on when the depletion region for the PN is much smaller compared to the PIN. So when we have a higher depletion region, we can produce a bigger electric field. So it will the electron hole pair will be much faster to go to the the site.
Drift. Use the word drift, not go.
Drift.
Okay, good. So I hope the rest of you understand lah. There's a difference between PN, PIN, photodiode.
Afiq has question.
Yes, Afiq.
What are the parameters involved to improve the speed of photodetector?
Okay.
So
Haris,
the first one is the electric field itself. So you need to increase the reverse bias of the photodetector. The next one, next is, I think the main factor is the electric field itself, like the reverse biasing.
So the speed depends on the speed of how the carriers move.
Yes.
So electron will be faster than hole. So that's why some when they design the photodetector, they use more of the carriers, the electron punya detection daripada hole. Dia ada cara untuk buat benda tu lah, to suppress the hole and to depend on the electron conduction. Walaupun sebenarnya ada dua both. And also there's electric field. You make it the electric bigger, then the faster because the hill to steep, you have a faster drift, so you get higher speed. Okay. And also speed of the carrier also depends on the material. We'll talk about before kan, the speed and the temperature and everything. So scattering will reduce the speed. So then the other parameters that affect semiconductor material will affect photodetector. Sebab tu kita belajar awal-awal tu semua basic tu. Muhaimin, next question to you. How does avalanche photodiode work?
Alamak.
Bigger because your Amirul Faris explain about bigger built-in voltage. Saya tak faham lah. Can you explain that?
Jap. Avalanche. Jap. Avalanche. Kalau PIN move to electric field. Avalanche we when we using Meon. Try
Sila.
Nanti sub saya. Okay, so bila avalan ni kita boleh cakap yang kalau jap ada hari tu on terang jap. Okay, compared this is belum jawab lagi soalan. Okay, compared to the PIN we increase the depletion region, but for the avalanche we increase the voltage, right? The voltage, right? Meon. Kan? Betul kan?
So apa voltage apa? Built-in voltage or what voltage?
Built-in voltage
Saya tak sure saya buat built-in voltage atau reverse bias voltage.
Reverse bias voltage rasanya.
Reverse bias voltage rasanya.
Rasanya yang tu yang betul.
Yes, reverse bias voltage.
So awak sebut salah, awak baca boleh tengok recording awak balik kan?
Baik. I'm sorry, madam.
Okay, mungkin itulah nervous kot tersalah sebut, tapi dalam exam if you say that potonglah markah lagi. Okay, so be careful kalau dalam exam, make sure that you, kalau salah saya bukannya tak bagi markah, saya akan potong markah sebabnya it gives another meaning to it. So it shows that you really don't understand. Kalau tak jawab tu saya tahu tak faham. Kalau salah faham tu lagi teruk. Kalau tak faham satu hal. Kalau salah faham tu lagi berdosa lah daripada tak faham saya rasa. Sebabnya kena be careful when you write anything in the exam. So basically it's due to the voltage. You make the reverse bias voltage bigger, therefore there will be impact ionization. It's not the built-in voltage. The built-in voltage is memang benda tu kalau kita tak PN tu banyak tu lah kita boleh ubah dah.
Yes.
Okay, saya banyak soalan pasal yang APD ni sebab saya tak faham bila awak explain. Mungkin awak mungkin saya tahulah kalau awak faham ke tak, tapi kawan-kawan awak yang lain bila APD tu mungkin you want to read extra. Sebab saya tak ada masa nak tanya soalan yang sangat banyak. Siapa lagi saya tak tanya? Semua saya dah tanya?
Dah.
Semua dah tanya.
Saya ada soalan untuk Zarif, application. Sebab saya tak faham. Your friend yang cerita pasal application tu, yang CCD, CMOS tu, siapa explain?
Saya.
Haris.
Okay, so I will tanya Zarif lah. CCD dengan CMOS tu is actually apa nama ni, photodiode ke? CCD. Yang Haris explain. Is it actually when we talk about semiconductor now we talk about photodetector or PN junction. Is that PN junction? Teka lah, ya ke tak?
CCD and CMOS yes.
Oh, yes, it's a PN junction lah. Saya sahut teka lah tu. Okay, baik. Kita tanya yang explain tu lah, Haris. What's your answer to that?
Yeah, I think so as well because yeah. Ya, dia pakai photodetector.
So there are different types of photodetector. You have like gas photodetector, you have transistor photodetector, you have PN junction photodetector. So this CMOS, what type of photodetector is it using?
Transistor photodetector.
Yeah?
Transistor.
So topik kita transistor ke PN junction photodiode?
PN junction.
Okay, so maknanya awak dah keluar daripada tajuk lah kan? Alright, so be careful lah everybody else when you read this. The CMOS, CCD mostly are using transistor as the photodetector. It's not using PN junction.
Ya, saya ingatkan dia tambah transistor to the PN junction. My bad.
Oh tak, dia memang guna transistor tu as the detector. Okay. Satu lagi yang last tu application tu bila Haris explain, which I also don't understand. I think something not right. You talk about transmitter and photodetector. What's the difference? Do you remember when you explained?
The motion and object detection. The transmitter it produces light. So the light that it produces, once it hits an object, will bounce back to a photodetector.
Okay, that is clear. I think you need to watch your video again. I think masa tu you explanation tu tak clear, transmitter, photodetector yang mana satu. Okay, so the rest of you when you watch the video again need to beware sikit lah bahagian transmitter photodetector tu. Mungkin tak clear dan tak berapa tepat. Alright, thank you very much. I think this group, can you give a applause to the group? Kita bagilah. Saya bagi yang one. Alright, good. So let's go to the next one, which is laser. So I welcome Brother Afiq you need to share your screen. Please share your screen and you can do please give extra attention to laser. You can ask Afiq, the expert, any question. So on laser ni saya rasa Afiq je yang akan present dalam kelas. The other sister group will only present to me personally due to personal reason. Okay. So for you to learn the laser dengan Afiq je. Okay, silakan Afiq.
Hello, Assalamualaikum warahmatullahi wabarakatuh. Can you guys
20 minutes from now? Okay.
Okay. Oh, no, sorry. All right. Today I will be presenting about semiconductor laser, and so let's go to what is laser. So laser is light amplification by stimulated emission of radiation. So this is two key points that we need to remember is light amplification and stimulated emission. And so what are the properties of laser? So there are three basic properties of laser. The first one is highly monochromatic, which is the line width of the emitted photon is very small. And then the secondly is spatial coherent. What spatial coherent means is that it usually has a fixed phase of the wave of the laser itself has a fixed phase. And the thirdly is a temporal coherent, which is it has a strong correlation between electric fields at different time. So basically what happened is that the radiation that being emitted by the laser itself is highly in phase. So let's go towards semiconductor lasers. So semiconductor lasers, the structure is very similar as LED. So so the transition is happening in between energy bands. So for example, like the electron would flow from the conduction band to valence band, and then or vice versa, which is whole from valence band to the conduction band. And the line width is also extremely small. And because of that, the cons of line width is very small is that this device, semiconductor lasers could be affected by the temperature. And then we go to the active region, which is narrow, which is usually less than 1 micrometer. And this is due to the high doping. The advantage is we can have like a highly compact laser, but the cons, it would cause high beam divergence. And the three, it must be also highly monochromatic. And by monochromatic means it will only emit like one type of laser wavelength. And then we go towards a 4. Lasing action is depending with current, which is easy to modulate at high frequency. So what does it mean by lasing action? Lasing action is like we are generating a coherent beam of light at a single frequency. So that is what lasing action, which is laser itself. And to understand more about this, we will go more further in detail. And for the 5, we have optical resonators. What does optical resonators mean? Optical resonators mean it's actually have like sides that are reflective and that side are that partially reflecting. I will explain on it further later. And number 6, this is one of the most important thing, which is it must be a direct bandgap materials. It's the same as LED. The thing is that because we want to produce light, which is produce photon energy, only direct bandgap materials are producing photon energy. And let's move on. So this is an example of laser structure. So you can see there are two types. This is like two types of laser structure. The first one is Homo junction laser, which is both are the same material. And the second one is hetero junction materials, hetero junction laser. So the first one, the top and bottom layer has a for example, like what is it called? Aluminium gallium indium arsenide, and then the middle part, the example of the material is a gallium arsenide. So we will like go on the importance of each layer later. So as you can see for this part, the different material is the one that become active layer for the heterojunction. But since the homojunction laser doesn't have different layer in the middle, so this part, the dotted part, it would be the active, the one that would be active layer, the one that depletion region. So before we move on, there are three main components of energy conversion process. The first one is absorption. What absorption means is that, for example, like if there is like electron is moving from the valence to the conduction band, then when the photon pass through, then it would absorb the photon. And then the second is we have also spontaneous emission, which is like when the recombination occurs from the 2 to 1, and then the photon will be released. But stimulated emission, which is a very important part of this laser, is when there is a photon that is passing through, when the recombination occurs at the same phase and the same frequency and the same direction, and then what would happen after that, after it passed through it, will become, the output will become like 2 photons in phase. So which means like you have like the previous photons coming in, and then you have, after it passed through, then you have another, it become 2 photons in phase. And then we go on to the next component of laser, which is the optical resonators of the laser. So the reason that, or why we need the optical resonators is that if you see here the part that we put the name as HR, right? This HR part means highly reflective surface, which means it acts like a mirror. And then like we have also this partial reflective surface, which is the act like as a pass through. So what happened is that during the inside here, during the active region, when the photon is released, the photon is not only released on one direction, the photon will be released in many directions, right? That's why this highly reflective surface is very important, so that the photon is not going out at at every single sides of the laser, and it's only going out at a single portion of the partial reflective surface, which means like everything inside the photon in here would be bounced to everywhere, and it would come out at the partial reflective surface. That is for Homo junction laser. But the for hetero junction laser is a little bit different. Since we have for example, here we have aluminum gallium arsenide, and we have the middle layer is gallium arsenide. The difference is that the material in the middle should be higher in density. The reason is that we want to capitalize on the what we call as critical the total internal reflection. So what happened is that the photon will be generated inside this region, but what happened is that the photon would be focused in the middle, in the active region here. And this is a critical angle calculation. Critical angle calculation means that when you have like lower density and then you have medium density, this is like if the angle of the reflection is more than the critical angle calculation, the light will be reflected totally inside the active layer here. And that is the difference in between like Homo junction laser and hetero junction laser, and that's how the optical resonators function. And then we go for energy band diagram of Homo junction laser. So the thing about laser is that first we want very high carrier density to be for the recombination to occur. Yeah, so the p-n junction must be highly doped, and so what happened here? Because we dope it highly, and then the Fermi level of the, for example, like for p junction, the Fermi level would drop further than the valence band. The reason is that because we dope it too high, so the Fermi level become more than valence band. That's why we call it as degenerately doped. And for the N junction, the Fermi level would be increased more compared to the covalence energy band because of the degenerately doping. This doping is because we want to increase the number of electrons on this covalence band for the N, and we want to increase the number of holes in the
conduction band. It's not covalence band, it's conduction band.
Conduction band, sorry. The conduction band. And sorry. Give me a second. So we want that so that there are more electrons here and more holes are here, so that the recombination can easily open in a very, very large scale. So in order to, previously we did talk about the stimulated emission and the absorption emission. So in order for us to increase the stimulated emission compared to the absorption emission is that we need to put a forward bias current. So this is a zero bias energy band diagram. And so this is what it will look like. And so the bottom, the blue line shown the Fermi level, and the bottom part here, everything is actually electrons, and the top part of the Fermi level here is holes. So as I said before, in order to in order to increase the stimulated emission rate, well, we need to put the forward bias. So what happened when we put a forward bias current is that, so the depletion region would become become smaller, and then so it will look like this. So the Fermi level is not exactly it's not the same at the same level already, since the depletion region become very smaller, become smaller. But then here we have more electrons on this part, and then we also have more holes on this part. So what happened here is that, so when electrons is going, when electrons recombine from the conduction band to the valence band, and then it would produce the HV, which is the photon radiation. The E2 here is the 0.2, and then here is 0.1. So what does it mean is that the radiation would be E2 minus E1. So in this case, since we have more electrons on this part, so this is also what we call as a depletion region or active region, and the recombination would happen at the very, very high scale. And there will be a lot of photon emission occur. And we also have a heterojunction laser, which is the small band gap semiconductor in between two larger band gap semiconductor. So as demonstrated here, we have a gallium arsenide and we have aluminum gallium arsenide, which are on the left and right. And the thing is that actually, well, this is like just to demonstrate like the Fermi level and the active region. So what happened here is that here the active region will be here for the electrons, and here will be holes, and the recombination would happen in the middle part. So HV equals to EG. EG is the same, is a energy band. So because of we have a smaller band gap, so in the active region, so it would require less current to obtain population inversion to start the lasing action. And then we go to the quantum well lasers. So as we know from before the heterojunction, because we can capitalize on the heterojunction heterojunction to make a quantum well lasers. So we can put the gallium arsenide in the middle at very much smaller scale, which is in few nanometer, and we can cause quantum confinement in this region, in which so the active region would be smaller, and then and we also only need a lesser current to produce a laser for because of this smaller active region.
You have 3 minutes left.
Okay. So so the usage is in medical therapy, in laser printing, and communication, which we require like smaller current but at higher density laser. And so yes, so, because of we also have like quantum well, we also there is also exists like quantum dot and quantum wire laser. And so the usage of laser, this is like the usage of laser. So small diodes allow there is like smaller laser diodes which allow fast switching and modulation of optical power. For example, like transmitter, fiber optic links. And secondly, it's used as a source of solid state lasers. which is like there right now we use this we use the diode lasers as a because like smaller solid state lasers with high voltage, we also need a source. So one of the source that it can use to for this laser is a semiconductor laser, and the third is the LVP laser voltage probe, which is what it does is that you shine laser on the on MOSFET or CMOS, and we would read we would read the how to say the modulation of this semiconductor, because laser itself has like fixed frequency already. So when the semiconductor pass through, it would change this frequency to be, and there is a so we can know like what is the rate of toggling of this semiconductor. This is what is laser voltage probing devices. So I think so this is the reflection, which is I picked this ayah, but and like وما تكون في شأن وما تتلو منه في قرآن ولا تعملون من عمل إلا كنا عليكم شهودا إذ تفيضون فيه وما يعزب عن ربك من مثقال ذرة في الأرض ولا في السماء ولا أصغر من ذلك ولا أكبر إلا في كتاب مبين. There is no activity you may be engaged in, O Prophet, or portion of the Quran you may be reciting, nor did you all may be doing, except that we are a witness over you while doing it. Not even an atom weight is hidden from your Lord on earth or in heaven, nor anything smaller or larger than that, but is written in a perfect record. So basically, if you want to relate, there is nothing that could be hidden from our side. Even in private, if we do sinful thing, and because Allah knew, there's nothing that could be hidden from him. But this ayah is not directly related to the laser. So I pick another ayah, which is like from Surah An-Nur, verse 35. Allahu nur samawati wal ard, masalu nurihi kamishkatin fiha misbah, al-misbahu fi zujajah, az-zujajatu ka'annaha kawkabun duriyun yuqad min syajaratin mubarakatin zaitunatin la syarqiyah wala gharbiyah. So basically, this ayah is basically explaining about the light, which is the light of Allah, which is also we can relate to the laser itself, which is in the crystal, which is we can relate to the optical resonator, and the crystal is like a shining star, and it also would almost glow even without being touched by fire. I think that's all from me. Thank you.
Okay. Thank you very much, brother. What's the time now? Okay, what's the time now? 11:15. We have 5 minutes before we end the class. I think you need to add some more to the presentation. Otherwise, the parameters are not clear. There's no section of parameters. Did you forget, or you purposely didn't put it there?
Parameters. Okay. I think I forgot.
Yeah, it's very important. So I'll give you a second chance. So for the next class, give you maybe 5 minutes to present on the parameters alone.
Okay.
Then we'll continue on the question and answer, and I'll also give you a second chance for Islamization if you want to try.
Okay. All right.
Okay. Maybe you need to discuss with other people. Try to discuss with a friend. I don't know. To just get the idea flowing. Sebab awak masters kan, so dia macam saya akan I will like a bit more. I will provoke you a bit more on the examination. So try to discuss with others. If you don't discuss, dia akan jadi idea kita ni tak bercambah. Okay, try to choose another ayah than the ayat 35. So semua orang pakai ayat tu. Kenapa ni? I mean, there are many ayah in the Quran. So just you need to think a little bit more. If the ayah, there's a lot of ayah on Nur, not only the ayah cahaya. So you need to reflect a bit more. Okay, and add on the parameters. The rest of you will have a question and answer next class, inshallah. Because actually I think tak tahulah from the rest of you, I don't know whether you understand lasers or not based on what Afiq's presentation. Then if you don't understand, you better ask next class. And Afiq, prepare yourself to answer question. Go and watch more videos if you don't really understand. There are a lot of good videos out there explaining how laser works. Okay. So laser ni complicated. So you need to make sure you really know what's the difference between LED and laser, and what's the main differences, and what are the important mechanism in a laser which is not there in a LED. Okay, and the parameters pun important lah. Okay, so I think that's all for today. Next class we'll have a little bit of Afiq and then question answer on the laser. Then we'll go to solar cell. Then finish lah. I think for the quiz, I'll give you the quiz next Thursday, whether we have time to make in the class. If not, you will take home. You need to time yourself and then make the question. Then next week we'll continue with BJT again sampai habis lah. Okay, kita ada berapa minggu lagi? Do you know?
This is the 9th week, I think.
9, 10, 11. Okay. Kita kena laju sikit minggu depan. I will try to finish minggu depan BJT, then we can go MOSFET. I'm thinking to make the final exam half-half. Half closed, half open. Open will be on the design question. And most probably it will be due to item 4 ni lah. So make sure you understand item 4 optical devices ni, you'll be designing one of them. The closed book will have all the theory part. Design ni boleh buka anything, right? So but you need to understand. Kalau tak faham masa tu baru nak faham, susah lah awak. Okay, so I think keep your question, make down, you jot down the question so that you can ask Afiq in the next class. Great. Okay, thank you. Let's close the class with a doa, please. Anybody? Ada yang tak pernah baca lagi? Ke semua dah baca doa? Semua dah baca? Ya, okay. Siapa yang so then we go the second round. Kalau semua dah baca, siapa nak baca doa?
Me, madam.
Okay, silakan.
Bismillahirrahmanirrahim. Subhanakallahumma bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Rabbi zidni ilman warzuqni fahman. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Rabbi yassir wa la tu'assir wa tamim bi khairika nasta'in. Amin ya rabbal alamin.
Amin ya rabbal alamin. So insyaAllah see you on Tuesday. Okay, assalamualaikum. Let's close. Tadi dah baca kan? Tasbih farah subhanakallah bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Okay, assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.